Chapter 9 is about a concept called hypothesis testing. It's also called inference, drawing inference from using a sample about the population parameters like mu or population proportion pi. So we'll be using these files. Okay, it follows the same pattern like the previous chapters. We have the PowerPoint slides. You need to use that to follow along with my lectures, and we have a formulas file in a PDF file. Print that, and you'll be using those formulas of very frequently. So you keep that on your side, and then we have the Excel shell file that you need to download and work all the problems from the shell file using the videos as guidance. So in this chapter, you learn what is hypothesis, the basic principles behind hypothesis, and how you should set it up. There are some very strict rules about how the hypothesis should be set up, and you need to learn those rules and be able to set up the hypothesis correctly. And how to use hypothesis testing to test a mean or a population proportion, the procedure. The assumptions that you need to go through the hypothesis testing procedure, and some issues involved in hypothesis testing. So these are the objectives. So what is a hypothesis? Hypothesis is about a claim or an assertion about a population parameter. So population parameter is the mean monthly cell phone bill in a city is $42. Okay, that is a proposition that we want to test. So that's about population mean mu. Or it could be a proposition about population proportion. So the proportion of adults in the city with cell phone is 68%. So that is again a statement, and we want to verify whether that statement is true or not, and that is a hypothesis. And we will verify the hypothesis using sample statistics. Okay. Now, hypothesis is set up as a pair of statements. Okay. One is called null hypothesis, and it is denoted by H subscript 0, and then an alternative to that null hypothesis, and that is H subscript 1. Okay. And there are, as I said, some basic rules that you must always follow. If you deviate from the basic rules, then you're going to have the hypothesis set up incorrectly, and the whole thing will be inaccurate, then erroneous. So the first basic rule is the hypothesis is always about population parameter. It is about the parameter, because population parameter is the unknown quantity. Okay, so it is about mu, or it is about pi, or it is about sigma, the standard deviation of the population. It is never about sample, because there is no need to hypothesize about the sample. So you have you take a random sample and you have the sample with you. You can calculate the average of that sample. Sample mean you can calculate, and you know exactly what it is. There is no need to hypothesize about what that population mean is. So stating HO like X bar equal to 30 is never correct. So you need to make sure that you write the hypothesis correctly. Never use sample statistic. It's always about population parameter. Okay, so that's one basic rule you must always follow. Okay. And the null hypothesis is about a priori statement. Okay, what you begin with. In legal terminology, it would be like a accused person is assumed innocent until proven guilty. So the null hypothesis is about the a priori condition. So the rights and privileges that are assumed. Okay? And only when a contrary situation is proved, then you reject the null hypothesis. Okay? So that's one overriding principle that you need to keep in mind when developing null hypothesis. Okay. Now the alternative hypothesis is always the opposite of the null hypothesis. You state the null hypothesis. So in many situations, people only state one hypothesis and do not state the other one, because it is always the opposite of null hypothesis. Okay, so even though you don't state it, it's always there. The hypothesis is always a pair: the null hypothesis and the alternative hypothesis. Okay. And the null hypothesis also refers to the status quo. You have a status quo situation, you want to put it in the null hypothesis. Another principle in hypothesis, the alternative hypothesis, is what is the condition that needed to be proven beyond reasonable doubt. The condition that needs to be proven should go in the alternative, because when you reject the null hypothesis and go with the alternative, then you can say that we have statistically proven the condition that is stated in the alternative. If you don't reject the null hypothesis, okay, that doesn't mean that you proved the null hypothesis is true. So if you put the condition that you needed to prove under the null, and even if you accept the null, you cannot claim you have proved it. So if you want to prove something, that condition should go in the alternative. Then only there is even a chance of proving it. Otherwise, you cannot prove it. Okay. Another technical requirement here is that you always, the equal to sign is always with the null hypothesis. So the null hypothesis is always going to be, so this is a universal thing again, it's a basic rule. Like you can't have X bar in a hypothesis. You need to have only the population parameters in the hypothesis. Similarly, this is again a basic fundamental rule that the alternative hypothesis will always contain either the equal to, or less than or equal to, or greater than or equal to. The equal to sign is always part of the null hypothesis. You'll never put the equal to sign in the alternative. So the alternative then has to be, as I said, it has to be the opposite. So if you have equal to in the null, the alternative hypothesis will be the opposite of that, which is not equal to. If you have less than or equal to in the null, then the opposite is the alternative, so which is greater than. If the null is greater than or equal to, then the alternative is less than. So suppose if you have a claim, somebody makes a claim that the population mean age is 50, and we want to verify that. So mu is 50, alternative is mu not equal to 50. So we have the population, we take a sample from that population, and we want to determine the veracity of the null and the alternative hypothesis. Suppose if you determine from the sample that you cannot reject the null hypothesis. So that means that the statement, the claim remains standing. It doesn't mean that the claim has been verified. It simply says you don't have enough evidence to challenge that claim, so you simply keep quiet. All right. So if you say so. But if the sample turns out to be such that you can reject it, for example, if the sample mean turns out to be like 25, then you see sample mean is so small compared to what the claim that is being made, then you can say, oh no man, I'm going to reject that claim. So in that case, you can say, so if if that 25 is far enough for you to make that claim, you have to mathematically show what is the probability that if the mean is 50, that your population mean is 50, a sample will have a mean of 25. And if that is near impossible, then you can say that such a case, such a sample is near impossible. So the problem is with your claim, and I'm going to reject that claim. Okay. So you either not reject the null hypothesis, which does not mean you prove the null hypothesis. You can you're simply saying, all right, I'm not going to say anything. But when you reject the null hypothesis, then you're saying, okay, well, the null hypothesis has no merit, so I'm going to go with the alternative. Alternative stands proven in that case.